This is question 5 from the second CSAT sample paper. Here we're given a curve C with equation y squared plus 2y equals x cubed plus 7x, and we're simply asked to find the gradient at all the points where x equals 1. So if you want to have a go at this question yourself, pause the video now. Okay, so first of all, it's possible you're not familiar with the technique I'm going to use, which is implicit differentiation. If you're not, it should be easy to follow what I'm doing, but you might want to look up yourself why it works. Another way of doing this is to make this a quadratic in y, so treat this as just a number, bring it over this side. Either use the formula or complete the square to get y equals something in terms of x. You should have two answers with a plus or minus, and then differentiate those, but you would need the chain rule in order to differentiate that. But let's do it implicitly because it's easier. So when we differentiate implicitly, we're differentiating with respect to x, so this side is fine. This side, what we do is we differentiate with respect to y, and then we just multiply everything by dy by dx. So let's look at what we get. This side, differentiating with respect to y, we get 2y plus 2, and then we multiply everything by dy by dx. And on this side we get 3x squared plus 7, just differentiating normally. And now we want dy by dx because we want the gradient. So if we rearrange, we get dy by dx equals 3x squared plus 7 over 2y plus 2. And bear in mind we're going to be using x equals 1, so we can just make the top 3 plus 7 is 10, then cancel 2's, so this becomes 5 over y plus 1. So now we need to know what y is at those points where x equals 1, so we're going to have to go back to the original equation and then plug in x equals 1. So when we put in x equals 1, we have y squared plus 2y equals x cubed is now 1, and 7x is just 7. So we get y squared plus 2y equals 8, or we could bring the 8 over this side to make something we can hope to factorise. And in fact it does factorise. It factorises to y plus 4, y minus 2. This is 0. So we want y is minus 4 or 2. And I've put a 1 by this and a 2 by this because these are our two cases. So I'll work out dy by dx in each of these cases. So in case 1, what is dy by dx? It's 5 over y plus 1. Here that's 5 over minus 3, or minus 5/3. And in the second case, we just have 5 over 3, and that doesn't need any simplifying. So our answers are effectively plus or minus 5/3.